Good morning, students. Today we are going to see the topic of modulation in communication system. So modulation are of two types, analog and broadly divided into two types, analog and digital communication. So like modulation is the process of like transmitting signals, communication signals. So through communication media. So modulation is the process actually like varying parameter from a low frequency carrier signal to the high frequency modulating or the information signal. So this is how like a modulation refers to, and modulation actually helps to avoid interference and to communicate or transmit multiple signals at the same time in the communication medium, So it helps to actually reduce the antenna size also. So this actually we are going to see today is the amplitude modulation. There are three types of modulation like frequency modulation, amplitude modulation and phase modulation. So phase modulation and frequency modulation are referred to as angle modulation. So today we will see the topic of amplitude modulation. So amplitude modulation is the process of transmitting the changing signal, okay, like with the low frequency carrier signal in accordance with the high frequency modulating or the information signal. So if we are varying the amplitude of these two signals, we are referring to that as a amplitude modulation. If we are varying the frequency of the signals, we are in accordance with the modulating signal or the message information, we will call that as a frequency. Again, the phase is being varied between these two signals, we will call that as a phase modulation. So now like we will see like AM concept. AM concept refers to mostly by varying the amplitude signals. So likewise we will see what do you mean by AM waveform. So how a waveform looks like. So for example, now like we will see the high frequency modulating signal. So here we have the process of AM takes place, amplitude modulation. After amplitude modulation, this is going to be the high frequency. So this is called the AM envelope after the amplitude modulation. So here what happens is this modulating signal is a low frequency signal and this is a high frequency carrier signal. So in amplitude modulation, so the process of just varying a parameter of low frequency carrier signal with a high frequency modulating signal, and after the modulation you can see like how it is being, the amplitude is being varied inside the envelope. We call this as a AM waveform, and the higher peak we always referring to PC plus VM. means like it is nothing but the message and the carrier amplitude is the sum of message in the carrier amplitude. When you see the lower peak, so we call this as a DC minus VM. So since it is a negative peak, so this is how the amplitude modulation waveform looks like. And now let us see the mathematical representation of AM model, AM signals. It's actually an analysis. So the analysis wise, when you see, so it is the signal of AM modulation, the envelope means like after adding the message and the carrier. So AC plus the message information signal. Okay. So here nothing but we will see. So AC we will take out message signal and the cos of omega. Okay. So here we will take AC outside and we will see AC so 1 plus 1 by AC into M of T into cos omega C T. So here we call 1 by AC is nothing but the KA. KA refers to the sensitivity of amplitude modulation. So here again like omega C or A M of T is nothing but AM into cos of omega MT. So here we will substitute. So when we substitute in this, we will see like 1 plus 1 by AC will become AM into AM by AC into cos omega M. Cos omega C. So AM by AC AM by AC is referred to as MA, which is called as the modulation index. So modulation index is nothing but the ratio between the amplitude modulation, modulating signal, amplitude of the modulating signal to the one carrier signal, amplitude of the carrier signal. So now we just take AC by into 1 plus ME into cos omega MT into cos omega CT. So which is nothing but AC plus ME. So AC cos omega CT plus AC into MA is nothing but AM by AC, where MA is AM by AC. So we will cancel out and we will keep. So the formula of cos A cos B, cos A cos B is nothing but 1 by 2 into cos of A plus B cos of A minus C. So here when we see, we write AC, which is nothing but AC is cos omega C2 is nothing but the carrier information. And this is nothing but the side bands. So side bands always will form when you are generating or transmitting the signals of amplitude with the high frequency in accordance with the modulating information. So we are getting here half into AM cos omega C plus omega into T. This is referred to as the carrier. This is referred to as the side bands. Side bands are usually generated after the modulating signal or after modulation is done. So this is the upper side band and this is the lower side band. So addition of these two we will get as side bands. So the overall, this is the time domain of the amplitude modulation, and when we take the time domain, we will see this as a double sideband DSB full carrier amplitude modulation. Means we are getting the two sidebands here, upper and lower sidebands, and we call this as a full carrier. So that is how we call this amplitude modulation as DSB. So this is how finally we will get the expression in the representation of carrier plus the sideband signals. So we will call, also we have a suppressed carrier double sideband amplitude modulation also, where the carrier is suppressed and we will get not the full carrier. Again we have sideband suppressed carrier also, sidebands of the amplitude modulation, where we have only the sidebands, we do not have the carrier. We will not be using the carrier for the transmission of the signals. Instead we always use for the modulation the sideband signal, which is nothing but the upper and the lower sideband. We also have one more method of modulation, we call that as a vestigial sideband. So vestigial sideband is something like one sideband will be partially depleted and another sideband will be fully acquired for the transmission of the signals from transmitter to the receiver.